Open the fabric pieces cut from the used garments into small tufts. Step 3. Shred the small tufts into fiber clumps and remove impurities. Step 4. Convert the clump materials into slivers, that is, uniform strands of fiber. Step 5. Draw a number of slivers together to form straightened units with improved evenness. Step 6. Feed these drawn slivers into a high-speed rotor and spin into a single yarn. If a lighter and smoother hand feel is needed for the end product, ring spinning can be applied here. Step 7. Twist single yarns into ply yarn to enhance strength and balance torque. Step 8. Make new 3D knitted products, such as sweaters and dresses, or create knitted panels, such as scarves. In G2G's second phase, automation and capacity have been improved by the development of an AI algorithm, which examines a garment's measurable properties, and the installation of a 3-in-1 fiber processing system. Production capacity has doubled, while manpower demands have been reduced by 35%. A vision classification algorithm has been developed to determine the setting of process parameters and automatically check for unopened fibers. An add-on feature, a 3D body scanner, records accurate body measurements, ensuring that the recycled garment fits well. The G2G's first retail model, named Loop, was launched in 2020 in an H&M store in Stockholm, Sweden. G2G is a critically acclaimed project and continues to offer an innovative and sustainable contribution to pressing environmental concern.
Quite nice, huh? Okay, you should all come to visit us in Hong Kong. And continue with the textile closed loop, we have developed various recycling technologies specific for different materials, as it's important to recycle the materials separately in order to maintain the fiber quality. For polyester and cotton blended garment, a hydrothermal solvent process is able to separate polyester and cellulose separately. These fibers could be respun into recycled yarn for textile application. And interesting is that the cellular powders that we obtain could be transformed into a super absorbent particles, which could be used for farming in agriculture. This will help in the cotton growing countries. And another interesting textile closed loop technology is for nylon textile recovery. This process is highly selective to recycle nylon from textile waste. And the good thing about this process is highly specific, and only nylon can dissolve in this system. And other common fibers, both natural and synthetic, are unaffected. This is the video to show you how efficient nylon could be dissolved in the solvent. In this video, only 2 minutes, the nylon is completely dissolved, and the whole reaction occurs at room temperature and atmospheric pressure. And the whole process flow from garment waste to nylon recovery is very simple, from dissolution to recovery and respinning. And more importantly, the solvent we use could be regenerated and reused at a very high rate. This is to show you the beauty of this technology. The nylon is completely removed from the spandex, and these two materials could be recycled separately. And the dissolved nylon will then be made into nylon chips and respin into fiber for garment making. And the good thing of this technology is that it could apply in all different nylons, including nylon 66 and 56 from blended textiles. And there's no significant reduction in the nylon molecular weight, meaning that the recovered nylon is at high quality. and the whole process is low energy consumption and highly efficient. We have also conducted LCA analysis on both the virgin nylon production and on our developed recycle process for nylon 6 and 6X. Results shows that the recycled nylon using our technology, there is a reduction in the damage to human health and environment when compared to the virgin nylon, meaning that recycling nylon is more beneficial than the production of nylon. And up to now, garment textile recycling has been very limited along the supply chain due to the vast investment company has to invest. In Hong Kong Retail, we have developed an automated recognition and sorting technology to solve this problem. The used garment can be sorted into different categories according to garment type, material, color, and fabric structure. This system is, this system which could identify garment according to the type, material, color, and fabric structure. This system is very useful in handling large amounts of old garments with efficiency and accuracy. And the sorted garment could be resold and reused to extend the garment life. If the garment could not be resold or reused, then it could pass to for fiber recovery. And good thing about this system is that it could adopt into different business models. This is the typical pictures that we take for garment identification. The important feature of this garment type identification is that the garment doesn't have to lay flat or put on mannequin. This will greatly reduce the manual input for the garment sorting. And the model has shown that the accuracy for identifying the correct type can achieve over 90% for some categories, and we are still improving on the model. Fabric structure is also important for garment recycling, as the structure determines the subsequent recycling technology. And for material identification, it is important for waste management because accurate labeling can provide us important information on valuable fiber and for the technology we choose for recycling these fibers. Color is also important for garment and waste management. This is because often we will collect the garment of the same color and the same material so that the recycling process is more efficient and less energy consuming. And microplastic is also a big domain for sustainability because it affects our ecosystem and biodiversity. We have evaluated the microplastic release along the textile production process and developed a microplastic management tool and suggest prevention on where we could intervene the microplastic release. We have also used acoustic waste for microplastic management in wastewater. We have also used a biomethod and identified a group of microorganisms from nature that could digest polyester, acrylic, and nylon fiber effectively. And this group of microorganisms could be applied for microplastic treatment in textile sludge and landfill, where most of the microplastic occurs and released into our environment. An interesting thing is that from this group of microorganisms, we have developed new enzymes that could depolymerize PET to its monomers, which is good for PET recycling, for producing virgin quality of recycled PET. I think this is an excellent example of how one research outcome could lead to the next technology development. Last but not least, technology is here to help people. We have developed different performance for different sectors such as athletes, elderly, workers against different conditions or adverse climate. So to make our society a better place. Last, I would like to make a conclusion that technology could actually help sustainability, but I think it's every one of us a choice that could preserve the earth for the future. Thank you.
Cảm ơn Erika Ngan. Hội thảo của chúng ta đến đây là kết thúc. Cảm ơn.
Thank you, Erika Ngan. Our seminar ends here. Thank you for coming.
Thưa quý vị và các bạn, buổi hội thảo tiếp theo trí tuệ nhân tạo trong việc tự động hóa quy trình kiểm tra vận tải. Trí tuệ nhân tạo trong tự động hóa quy trình kiểm tra vải truyền thống của ngành dệt may và thời trang, thách thức và cơ hội sẽ bắt đầu trong 1 phút nữa. Xin lưu ý rằng hội thảo này sẽ được tiến hành bằng tiếng Anh và có dịch đồng thời sang tiếng Việt. Vui lòng đến cửa ra vào để mượn tai nghe.
Ladies and gentlemen, the next seminar, AI for Automating the Conventional Fabric Inspection Process of Textile and Apparel Industry, Challenges and Opportunities, will start in 1 minute. Please note that this seminar will conduct in English, and Vietnamese simultaneous interpretation is available. Please process to entrance to borrow the headset. Thank you.